In section 7.5, we're going to look at solving square root and other radical equations. Let's keep in mind that solving means we're actually going to find a value of x, and equations means that there is an equal sign involved, so that's how we can solve it. So let's get started. Example 1, we're going to solve square root equation. We're going to solve this equation, and if you notice, the x is underneath the square root. So in order to solve these, we're going to need to get this square root all by itself. So first we're going to add 10 to both sides. Right, now that we did that, in order to get rid of this square root, we're going to square both sides. Keep in mind, whatever you do to one side, you need to do to the other. So when we square the square root of 2x plus 1, we just get 2x plus 1. And 5 squared is 25. Now this is just a standard algebra equation. We're going to get that x by itself, so we subtract 1 from both sides. And finally divide by 2. And so this is our final answer. Remember, in solving, we're trying to get an actual value for x. All right, let's look at the second example. Sometimes we may need to check for extraneous solutions. Extraneous solutions are solutions that we may get, but that aren't actually true. So what we'll do is we'll find our solutions for x and then plug them back in and make sure that this equation is true. And really, extraneous solutions you need to be aware of when there's an x in a square root or a cube root or something and an x not in. That's when we really need to check for extraneous solutions. So once again, we're going to get this square root all by itself. So we're going to add 3 to both sides. And now to get rid of the square root, we're going to square both sides. The left-hand side is just going to be x plus 2. And the right-hand side is really 2x plus 3 times 2x plus 3, because it's 2x plus 3 squared. So we're just going to FOIL. We can combine like terms. So now we have a quadratic on this side and a linear on this side. So we're going to just put everything on one side so that we can solve this quadratic. So we'll subtract x from both sides and subtract 2. On this side, we'll get 0. And on the right side, we subtract x, we get 11x. Oh, that's a positive. And we subtract 2, we get plus 7. So now this is a quadratic. Let's try to use tic-tac-toe to see if we can solve it. So two numbers that multiply to be 28 and add to be 11 actually happen to be 7 and 4. The greatest common factor between 4 and 7 is 1. Greatest common factor between 4 and 4 is 4. So our terms are 4x plus 7 and x plus 1. Okay, keep in mind that in order for us to multiply these two things to get to 0, one of them at least has to be 0. So let's set them each equal to 0. We get 4x plus 7 equals 0. So 4x is negative 7 and x is negative 7 over 4. And then x plus 1 equals 0. So x is negative 1. Now we need to solve. Check for extraneous solutions. So we're going to stick both of these in there and see if they're actually true. So let's try x equals 1 first. So when we do that, we get the square root of negative 1 plus 2 minus 3. And I want to know, is that really equal to 2 times negative 1? So the left-hand side, this is 1. The square root of 1 is 1. And 1 minus 3 is negative 2. And on the other side, we get 2 times negative 1, which is negative 2. So this is a solution. Let's look at the other one. So negative 7 over 4. I'm going to write it down here. So we get the square root of negative 7 over 4 plus 2 minus 3. I want to know, is that equal to 2 times negative 7 over 4? This is, well, we can rewrite 2 as 8 over 4. And 8 minus 1 is 1/4. The square root of 1/4 is 1/2 minus 3. And on the other side, we get 2 over 1 times negative 7 over 4 is negative 7 over 2. And this is negative 5 over 2. So they are not equal. So this is not a solution. Our only solution is x equals negative 1. Go ahead and try this quick check. Keep in mind you have to get the square root by itself first, and you need to find a value for x. When you're finished with that, try quick check number 3 down here. The second part of this lesson has to do with solving equations with 2 rational exponents. So in this case, these have rational exponents. Remember, that's another word for fraction. So what we're actually going to do is we're going to separate them and make sure that one is on one side of the equation, or the equal sign, and one is on the other. So we're going to get x plus 1 to the 2 over 3 equals, we add this to both sides, we get a positive 9x plus 1 to the 1/3. So we can get rid of that cube root. That's essentially what that denominator is, remember, by cubing both sides. That gets rid of that 3. That gets rid of that 3. So we end up with x plus 1 squared is equal to 9x plus 1. Okay, keep in mind this is really x plus 1 times x plus 1, so we're going to FOIL. So we get x squared plus 2x plus 1. I'm going to trust that you can understand where I got those pieces from, equals 9x plus 1. And just like we did in the other one, let's get 0 on this side and the quadratic on this side. So I'm going to subtract 9x. I'm going to subtract 1. Okay, well, we can factor this. They actually both have an x in common. So we end up with x times x minus 7. That's completely factored now. So we can set each of these equal to 0. So we get x equals 0 and x minus 7 equals 0. So x equals 7. All right, it says we need to check for extraneous solutions. So let's plug these back into the original equation. Let's try 0. So we would end up with 0 plus 1 to the 2/3 minus 9 times 0 plus 1 to the 1/3. And I want to know, is that equal to 0? Well, 0 plus 1 is just 1. 1 to any power is 1. And then on this side, 9 times 0 is 0. So this ends up being 1 inside of here, and 1 to the 1/3 power, that's just 1. So 1 minus 1 is indeed 0. So that isn't a solution. It is a solution. So let's try x equals 7. So we end up with 7 plus 1 to the 2/3 minus 9 times 7 plus 1 to the 1/3. And I want to know, is that equal to 0? All right, so 7 plus 1 is 8. 8 squared. Well, let's look at this. The cube root of 8 is 2, and then 2 squared, this is 4. On this one, 9 times 7 is 63. 63 plus 1 is 64. Well, what's the cube root of 64? 4 times 4 is 16, times 4 is 64. So 4 minus 4, 0 equals 0. Both of these are solutions. Go ahead and do quick check number 4 on your own. Remember, you're going to get both of these, one on either side, and then you need to get rid of the square roots. Don't forget to check for extraneous solutions.